Alright, we're going to go ahead and go through the Unit 1 test review. Let's start off with graphing a piecewise function. So for this function I have three separate functions. My first function is 2 minus x. The easiest way to do this is to use a table of values. You could also graph this using the slope and y-intercept, and then do all the values that are greater than or equal to -1. But this is, however, where we're going to start our table, a -1. And then we're going to choose values that are greater than or equal to -1. So that would be -1, 0, 1, 2. And now we're going to see what happens to this function when I plug them into 2 minus x. So 2 minus -1 is actually 2 plus 1, which is 3. 2 minus 0 is 2. 2 minus 1 is 1, and 2 minus 2 is 0. So now I'm going to graph those coordinates, -1, 3. Notice I do have a closed circle on that point because of this equal to sign. Over 0 up 2, over 1 up 1, and over 2 up 0. And now that keeps going in that direction, so I'm just going to draw a line. This next function is a horizontal line at 3, and that's only from -2 to -1. And notice those are open circles on both of those points. So from -2, and notice that it's going to go from -2 to -1, and it's already a closed circle, so it's really just going to be this little portion right there. And so it's kind of hard to see to graph. And then finally x squared, and again you can do an xy, but you're going to start at -2 and do values less. So -2 squared is 4, -3 squared is 9, 16. So -2, up 1, 2, 3, 4. Again, that's a solid dot because of the equal sign. And then -3, 1, 5, 6, 7, 8, 9. And then it's going to keep going up from there. It's going to be a little curve right there. Alright. For number 2, we're going to graph this function and fill in the properties. So I'm going to graph 0.2 times 3 to the x power. Notice this is an exponential function. It's actually kind of also a growth model because of the 0.2 times 3 to the x. 3 is going to be your y-intercept. So if you look at this on the calculator, you can kind of see what this looks like. You can do a second table, and you can see where exactly, actually, excuse me, your y-intercept is at 0.2, not 3. So let's go ahead and change that. So you can use then this table of values to graph your function. Notice that this function is still approaching 0. It gets closer and closer to 0. It just never quite touches it. So again, your y-intercept is here, and it kind of goes up from there, and then you have an asymptote at the x-axis. So it's going to kind of go up like this. Okay. So your domain is really all real numbers from -infinity to infinity. Your range is from 0, not including 0, to infinity. It is increasing on the entire domain. This is increasing from left to right on the entire domain. It is not decreasing. And your end behavior is the limit as x approaches positive infinity. So as x goes this way, the function goes to positive infinity in the range. And then as x goes to -infinity, the function approaches 0, the range value. So as the function goes, as x goes to -infinity, this function approaches the range value of 0. Looking at the next one, we're going to look at the types of symmetry. For this graph, there is no symmetry about the origin nor on the y-axis, so this is neither. For the next one, you do have symmetry. If I were to take this portion at the origin and rotate it around, I would have it around the origin, so that would be odd. The next one is on the y-axis, so that's even. Linear would be odd. And finally, the last function doesn't have either, so it would be a n. So remember, for even, we're looking for symmetry on the y-axis, and for odd, we're looking for symmetry on the origin. If it doesn't have either of those types of symmetry, it would be neither. Number 4, we're going to determine the following are even, odd, or neither, and showing algebraically. Okay? For this one, you're not responsible for showing that this is odd algebraically, but just know that it is odd because the sine function goes like this and like this. So you could take from here and rotate it around the origin and see that it was odd. However, these two you are responsible to show algebraically. So you have to show f of negative x and see what happens when you find f of negative x. So for this function, it's going to be negative x minus 4. And from there, there's really nothing I can do. It's not opposite because you don't get negative. And it is not the same function. So therefore, you know that this is neither. For this function, you're going to plug in again negative x. So you're going to get the square root of the quantity of negative x squared minus 4. And if I take the quantity of x squared, negative x squared, that's just going to give me x squared minus 4. So notice that I get back the same function that I started with, so therefore this is an even function. Next one, we're going to find the inverse of this function. So first off, I'm going to set it equal, take y equals the square root of x minus 1. I'm going to change x and y around, and then I'm going to solve for y. So to solve for y, I'm going to square both sides. So that gives me x squared equals y minus 1, and then I'm going to add 1 to both sides. So I'm left with f of negative 1 of x equals x squared plus 1. There is no restrictions on the domain of the inverse. Okay? Because I can put in any number there for x squared. There are restrictions on the domain, though, of the original function. Okay, we're going to prove algebraically that these followings are inverse. So to prove algebraically, that means I have to show that f of g of x is the same as g of f of x. And I have to show that they are both equal to x. So I'm going to first take f of g of x. And so that means I'm going to take 2 times the cube root of x minus 5 squared over 2, cubed, plus 5. So the cube root of something cubed is just that. So then I have 2 times x minus 5 over 2 plus 5. These 2's cancel. Then I'm left with x minus 5 plus 5. Minus 5 plus 5 is 0, so I'm just left with x. G of f of x, again, I'm going to do the same thing. G of f of x, I'm going to take the cube root of, put in the function 2x cubed plus 5 minus 5 over 2. So I took this and I put it in here for x. Plus 5 minus 5, they cancel, I get 0. The 2's cancel, so I'm left with just x cubed, the cube root of x cubed. And the cube root of x cubed is just x. So therefore, I've shown and proven algebraically that these two functions are inverses, because when I put g of f of x and f of g of x, I get x for both of them. Okay, so now I am going to write what relation is implicitly defined by the following two functions. So if I have these two functions, what function do I actually get? And for this, I just basically work backwards. So I know that if I square both sides, I will get y squared equals 12 minus x squared. And then if I add x squared to both sides, I will end up with x squared plus y squared equals 12. So that's basically all you have to do. And notice this is a circle, this is a conic. It's a circle with a radius of the square root of 12. Now I'm going to work to solve this for y. So I'm going to first subtract 3x squared. I'm I'm going to be left with y squared equals 13 minus 3x squared. And now I'm going to take the square root of both sides. So I get y equals plus or minus the square root of 13 minus 3x squared. So I have two functions, either the positive or the negative version. Okay, so for this I'm going to identify first the labeled points and write the coordinates. Then I'm going to use the provided function to determine the coordinates of the transform points, and then finally sketch the new graph. So first off, I'm going to determine my coordinates. I'm going to go from left to right. So 1, 2, 3, 4, 1, 2, 3, 4. So that's negative 4, negative 4. My next point is at negative 2, 3. My next point is at 0, 0. And my last point is at 1, 2, 3, 4, 5, 1. Okay. Now this transformation is telling me, first off, that this is a horizontal, and since it's a 4, it appears to be a horizontal stretch, but remember, this is not written in standard form, so this is actually a horizontal shrink by a factor of 1/4. Because I could rewrite this function as negative f of x over 1/4. Okay, plus 1. Remember, that's a standard form of horizontal and it's inside the parentheses. This is also a negative, so this is also a reflection over here. That would be the x-axis. And it's a translation, and again, that's going to move up, so that's a vertical translation up 1 unit. Okay? So those are the three things I'm going to have to do. So the horizontal shrink, okay, if it's going to take it and shrink it horizontally, that's going to affect the x value. So I'm going to actually be multiplying the x value by 1/4. A reflection over the x-axis is actually going to take the opposite of the y value. And the vertical translation up is going to actually add 1 to the y as well. Okay? So in this case, we want to first reflect it, and then we're going to move it up. So this point then is going to now become, first off, the x value, multiply the x value by 1/4. So if I multiply this x value by 1/4, that will give me negative 1. For the y value, I'm going to first take the opposite, then add 1. So the opposite of negative 4 is positive 4. And then if I add 1, that's going to make it 5. Next one, negative 2. I'm going to multiply that by a 1/4, so it's going to be negative 1/2. And then the 3, I'm going to take the opposite and then add 1, so that'll be negative 2. So the opposite of 3 is negative 3, add 1 is negative 2. 0, 0, I'm just going to get 0 again. And then same thing, reflecting opposite of 0, 0, add 1 is 1. And then finally 5, 1, multiply it by, that's going to give me 5/4. And then if I add, take the opposite, that's negative 1, and add 1, I get 0. So now I'm going to re-sketch this graph. So negative 1, 1, 2, 3, 4, 5. It's going to move that there. This point now is going to be here. Negative 1/2, negative 2 is going to be here. 0, 1, over 0, up 1. And then finally 5/4, which is going to be about here, 0. So this function now is going to go down. See how much it shrunk it? Then back up, and then it also took and flipped it and moved it up 1.